Skill 19, using corresponding parts of congruent triangles. Problem number 3, given line L is perpendicular to segment AB and L bisects AB at C. Prove that the length PA is the same as the length PB. Okay, so the first thing I want to do is prove that the two triangles are congruent, and then I can prove that the corresponding parts are congruent, and then with the definition of length I can prove that the two lengths are the same. So that's my plan on proving this. It's going to be an 8-step proof. So we start with what we are given, and that would be L is perpendicular to AB and L bisects AB at C, and that's our given. Okay, so the next thing I'm going to look at is right here, how these two are perpendicular. So I'm going to use the idea of perpendicular and the definition of perpendicular lines to say that they are right angles. So angle ACP and angle BCP are right angles, and that's definition of perpendicular lines. Okay, the next part I'm going to look at is the fact that if these are both right angles, then they have to be congruent to each other by one of our theorems that we've talked about. So angle ACP is congruent to angle BCP by the congruence of right angles theorem. Alright, step 4, we now should look at our other definition, the bisecting part. So the bisecting part, if L bisects AB, then that makes A and B the same. Okay, so that's my next step. So segment AC is congruent to segment BC by definition of segment bisector. Okay, from here, I'm going to look at another segment to try to get another segment congruent to something else. And I see right here that segment is the same segment in both triangles, so we can use the reflexive property with that one. Segment PC is congruent to segment PC by the reflexive property. Okay, step 6, now we have, if you look carefully, we have a side and then an angle that's congruent, and then sides that are congruent. So we can go side, angle, side, and say the triangles are congruent. Triangle PAC is congruent to triangle PBC, and that's by the side, angle, side postulate. Okay, so now we have to prove that two different segments on here are congruent, and then we have to prove that they have the same length. So that's where I'm going to look right here. PA is the same as PB, and that is from our corresponding parts. So then we should be able to, the lengths are the same. Segment PA is congruent to segment PB by the corresponding parts of congruent triangles. Finally, the length PA is equal to the length PB, and that's by definition of congruent segments. Problem number 4. Segment BA is congruent to segment BC. BD bisects angle ABC. We want to prove that BD is perpendicular to AC and that BD bisects AC. So this is kind of two proofs all in one. So it's a 9-step proof. So we start with what we are given, and then we look at where we can go to try to prove the triangles are congruent, and then we can decide with some definitions how things are perpendicular and bisecting. So the first thing I'm going to look at is this line here that is shared by both triangles and say that they are congruent for the reflexive property. So segment BD is congruent to segment BD by the reflexive property. Okay, so now I have to look at my given to see where I can go from there. So I know that BD bisects angle ABC. So that makes this angle the same as this angle. So that's my next step. Angle ABD is congruent to angle CBD by definition of angle bisector. Okay, the next step is we should be able to make the jump to say the triangles are congruent because we have a side, an angle, and a side. So that's my next step. Triangle ABD is congruent to triangle CBD by the side angle side postulate. Okay, the next step, I want to say that both BD and AC are perpendicular. That's my next step, is I want to say that these are perpendicular. Okay, before I can do that, I need to first say that the angles are the same and that the sides are the same too. We have two steps here. Angle ADB is congruent to angle ACDB by the corresponding parts of congruent triangles, and AD is congruent to CD by corresponding parts of congruent triangles. So from there, we can say that BD bisects AC because we know that these two are the same. So we say BD bisects AC by definition of bisect and congruent segments, putting those two definitions together. Okay, now the last thing is to say that our two angles are right angles that we know are congruent to each other. The measure of angle ADB is equal to the measure of angle CDB, and that's by definition of congruent angles. Well, if the measures are equal and they are on a line like this, then definition of perpendicular angles says that those two sides are perpendicular. So we say that segment BD is perpendicular to segment AC by definition of perpendicular lines. Okay, number 5. Given BE is perpendicular to segment AC, DF is perpendicular to segment AC, and BE is congruent to segment DF, and AF is congruent to segment CE, we want to prove that segment AB is congruent to segment CD. So this is, again, a very complicated picture, a complicated proof. It's a 9-step proof. So we start with what we are given, and then we're going to look at those right angles that we have, so we can say that they are congruent to each other. So I'm going to start there. Angle AED and angle CFD are right angles by definition of perpendicular. Angle AED is congruent to angle CFD by congruence of right angles theorem. Okay, so now the next thing I'm going to look at is segments. So I know that AF is equal to CE. And the reason that is because I know that the segments are congruent. So I can say that the lengths are the same. So AF is equal to CE by definition of congruent segments. Okay, so now if I look at AC, that whole line is multiple lines. Because it's made up of smaller lines, I can add those segments together to get the bigger line. So that's what I'm going to do next. I have AE plus EF equals AF, and CF plus FE, or EF, equals CE. Okay, so I'm adding this segment in both cases, from E to F. Okay, now from there, what I'm going to look at is I'm going to subtract things off that are in common, which, as I just said, that would be this segment right here. So I'm going to subtract that off and see what I'm left with. I do that because I know that AF is equal to CE. So I know that is equal to this, so I set them equal to each other and subtract. Okay, so I kind of did 2 steps there at once. And we have AE equals CF. Further say segment AE is congruent to segment CF. So AE right here is congruent to CF right here. And that's by definition of congruent segments. to look at is the fact that I have not used my BE as congruent to DF. So DF is right here and BE is right here, and they are congruent. So now what I have is side, angle, side, side, angle, side. So I can say those two triangles are congruent as well. AEB is congruent to triangle CFD, and from there I can make my final step to saying that my other sides right here are the same, and we're going to use our corresponding parts. B is congruent to segment CD by corresponding parts of congruent triangles. Those are your notes over skill 19, using corresponding parts of congruent triangles. Summarize your notes, do the rest of the practice problems, then you should be ready for your quiz.